Welcome back, everyone. So you're back with me, Emma, again. And for this week, we're going to be making a pasta rocket, aka a noodle rocket. Okay, so basically, what is this? We're going to be talking about rocket engines specifically. So let's just talk about them real quick. So there are three primary types of rocket engines. We have solid fuel, liquid fuel, and hybrid engines. And you're probably thinking that this is absolutely crazy because there's no such thing as a pasta rocket that's used in space. What the heck is that? All right, so let me explain. So a pasta rocket is basically a demonstration of a hybrid rocket engine. Hybrid engines use a solid combustible source and a gas oxidizer, like oxygen, aka O2. So in our pasta rocket experiment that we're going to do today, the pasta is a complex carbohydrate that acts like the fuel source, and the oxygen gas that will be produced as a byproduct of a chemical reaction that we'll discuss in a little bit will act as the oxidizer. All right, so now that we got that cleared out of the way, let's start. Okay, so first and foremost, lab safety. And I emphasize this because I literally wasn't practicing lab safety earlier as I was grabbing my materials, and this is no joke. I actually cut my thumb along the length of it and along my palm. You think you can see the band-aid a little bit through the glove this morning while grabbing some dry noodles. And here's actually pictures of them. Me with the band-aid, you can actually see a little bit of blood seeping through. And a little bit again. You can even see that they were taken maybe about a half hour to an hour ago. So lab safety first. This means your nitrile gloves, because nitrile gloves are impermeable to chemicals, or latex gloves are semi-permeable. Your safety glasses, which are definitely going to be a big one today. Long protective covering gear. A lab coat would be ideal, but we don't have a lab coat because I'm not in a lab. But I definitely do have a fleece, and I have long pants on, and I have closed-toe shoes. All right, so lab safety first, because seriously, I got myself uneven dry pasta, which I've been working with for literally decades and never happened, but it happened today, of course, when I was doing an experiment for the first time ever with dry pasta, and it happened. So lab safety first. Nothing is too innocuous for you. All right, so anyway, the materials we're going to need for today's experiment can be commonly found around the home. Or if you can't find them around the home, you can purchase them for a couple of bucks at your local grocery store. All right, so we are going to need some hydrogen peroxide. This is just regular hydrogen peroxide, 3%. I unfortunately couldn't find any updated ones in the store because of the pandemic. A lot of things are pretty short in supply. So I have some that I have lying around the house. This actually wound up expiring late last year, but it's the closest thing that I have considering the circumstances. We are going to get some uncooked tube pasta like ziti, penne, rigatoni, right here. Okay. And then we have a lighter for today. You can have lighter or a match. This is just a regular lighter that I had in my kitchen. Some dry active yeast. I'm using Fleischmann's because it's simply the cheapest, and it was one of the two that the store had in stock. But really, any type of dry yeast, bread yeast will work. Something like a screwdriver or a hammer and a nail, or even like a drill. Like, you're going to need that for drilling a hole into your container. Now you're going to want a container that comes with a lid. We have a mason jar here that comes with a lid. And we also have this one right here. Container that comes with a lid. You're also going to want a measuring spoon. I have a 1/4 teaspoon here, 1/4 to 1/2 teaspoon. It all depends on how much you're going to fill up your cup for. Okay. So now that we have that out of the way, first what we're going to do is punch a hole into the middle of the lid. So it's recommended that you use a mason jar lid, but considering this one, I use this one for food, and things are pretty much out of stock, I'm going to be using this one for my experiment. So what you're going to be doing is drilling a hole into the center, and you can do this a variety of ways, using a drill, how we said earlier, or a hammer and a nail, or even a screwdriver to poke your way through it. So I personally use a screwdriver in the plastic lid to poke it through. I found it safer and a bit easier to do it that way. And you're going to be super careful when you do this because sometimes it can slide around and you can seriously hurt yourself. So seriously, practice at your workbench. Make sure you have a secure grip on it. Be super duper safe. If you don't feel safe yourself, I didn't feel safe today really doing this on the mason jar lid. One, it's a food grade quality item. I know that the metal isn't really bendable and impermeable, and I was afraid I was going to slip and hurt myself, so I wound up using this lid. Earlier today, when I even tried pushing in a little dent, it didn't push in at all, just very slightly, and it slid off. I was like, nope, not worth the risk. So I'm going to use this one for today. So this hole you're going to be making is going to be pretty small into your lid, and it's going to fit the inner diameter of your noodle. The inner diameter will be something like this across it. See the inside of it? So this is obviously going to vary on the size of your noodle, your inner diameter. Okay, so now we're going to take our jar. How I said for today's purposes, I worked with this one. At the same time, I already punched in a hole in the center of the lid. I just did it off camera. And how I said, I used a screwdriver to do that because I felt much safer, considering that I tried poking a hole into this to even make a single dent. And it slid around, and I was afraid I was seriously going to cut myself. Okay, so we poked a hole into the lid, did that. And now we're going to take our jar and our hydrogen peroxide. And what we are going to do is fill this up about maybe half of the way. Okay, so open this up. I haven't actually ever opened this. It's brand new, so it should still be fine. I'm going to fill this up maybe about half the way to 3/4 of the way. All right, so here we go. That's about 3/4 of the way, as you can see. All right. Now, we're going to wind up adding our yeast. I'm going to be using pretty small amount, considering that the total volume of this is pretty small. It's maybe about 3 ounces total. Yeah, it's about 3 ounces, so it's a pretty small amount. So I'm going to be using just about 1/4 of a teaspoon of our dry active yeast. So just give me 1 minute just so I can open this up safely. I brought along a pair of scissors because I know if I rip it open, it's going to get everywhere, so just give me a second. Oh. 1 second, y'all. So my teaspoon that I have, my measuring spoon that I have over here is about 1/4 of a teaspoon. Okay, so that's our dry active yeast. Put that off to the side real quick. And what I'm going to wind up doing is actually dumping this yeast into our hydrogen peroxide that we have here in our cup. Now mixing the yeast and the hydrogen peroxide is going to produce the oxygen gas needed for the experiment. Now there's a chemical reaction that takes place between these two, meaning the hydrogen peroxide and the yeast. The chemical reaction that occurs is an exothermic reaction. Now, you're wondering, what is this exactly? Well, there are natural enzymes in the yeast that we have here that act as a catalyst that decomposes the hydrogen peroxide. So this causes it to release the final products of this chemical reaction to be pure oxygen gas, aka O2, and water, H2O. As you mentioned earlier, the hydrogen will be released as a gas and will be the oxidizer while the pasta is the fuel in our experiment. Okay, so let's put this on, dump it in, see our yeast, go. You're gonna put, you can start to see bubbling a little bit. I'm gonna rub it on. I'm not sealing it on, that's important. Just putting it on a little bit, I'm gonna just mix it up a little bit. You can even stir this up yourself, personally, if you want. You can start to see starting to bubble and starting to foam. That's really, really important. Okay, we put the lid on the jar. We don't want to seal it exactly. We're going to sit it on top of the jar. This is because if we screw on the lid and seal it, it can actually build up back pressure and wind up exploding, which is no bueno. So give it a little shake. We're getting the yeast going. You can see it bubbling, bubbling, bubbling. Shake it up a bit more. Oh yeah, look at that baby go. Oh yeah, that's a lot of a lot of bubbles. Okay, now we're going to put our noodle on top. Okay, and then what we do here, okay. Okay, and as we can see, there's a little flame that's going. You can see it's very, very slight from the noodle. There we go. Do we see it? The little flame? Awesome. Okay, so what it is, we're actually lighting the noodle, and we saw the gas that was bubbling up down below the jar, and the gas is escaping through the noodle. Now, the tiny hole in the center of our lid actually directs all the oxygen to flow through it. The noodle is actually the fuel in this case. The oxygen source comes from the hydrogen peroxide. You see that? Isn't that beautiful? Look at that go. It's going and going and going. See? Look at that baby. And you can see the oxygen being produced down below from the chemical reaction. All right, so the noodle is actually the fuel in this case, and the oxygen source, I'm just going to blow that out real quick. The oxygen source comes from the hydrogen peroxide that was decomposing from the exothermic reaction below. Now, the oxygen is liberated from the peroxide with the yeast product. With the yeast. The yeast contains an enzyme that catalyzes production of the oxygen. The production of oxygen from our hydrogen peroxide is an exothermic reaction, and it actually does become quite warm. And this is not even a joke. This actually feels pretty warm within my hands. I'm actually going to put it down because it's actually getting a bit too warm, and you can actually see the reaction still going on inside a little bit. If you can see below. Whew, that is smoky. Okay, so basically the oxygen gas is fed into the combustion chamber, which means the hollow middle part of the tube, as you saw here, where it is ignited, meaning via the flame that we lit with our lighter, and it burns steadily along the grains of the solid fuel source, which was the noodle. As we saw, that was continuous going, and it's still going. Okay, this burns essentially steadily through the core thanks to the flow of oxygen out becoming from the generator. Because of the heavy weight of the oxygen source and the lack of any nozzle to the direct thrust, the engine does not have the power to propel itself into the air. So, how this is similar to a rocket engine? Well, this is a simplified form, but a lot of the rockets, including this, are super advanced, use the same concept. And I'm not even joking, y'all. This is actually really, really warm, and you can actually see it was still going on. See how it's still kind of red? So I'm going to end this experiment, and I am going to go run to the sink and douse this underwater because this will not stop. Even after I blow it out, it is still going on just a little bit. We can still see it's kind of a little bit red, and it's still heating up. So thank you so much for coming, and if you have any questions or comments, please comment below.